everybody. Nice to see you here in this latest talk of the day. I hope that you found it interesting. And my name is Artur. I work as an Android developer. And in my free time and in my weekends, also I'm a GDG lead, Google Developers Group lead. By the way, have you heard about GDG at all? Please raise your hands if you have. Okay, and you have GDG in Oslo, yeah?
Yeah.
Okay, great. So yeah, if there are somebody from here, I will be glad to talk about different things. Okay, and so the first question is, how many of you are Android developers, native Android? Mostly. Okay, great. So often we work in small companies. Only some of us work in some larger companies, and we have to deliver features. And we deliver it. Often it works, kind of. And once we got into a very bad situation with this kind of, and we made it into it works well. And today I will show you how did we do it. And after this talk, you will not become a guru of profiling. However, I think that if after this talk you will come back to your job and decide that, oh, let's see how does it work actually, then I will think that my goal was achieved. So the examples will be with the app that we created for some time. It's about messaging. And today we will cover such things as UI rendering in Android overall, as should you try to solve anything at all, because if you don't have a problem, probably you shouldn't solve it. And how can you do it? If you have a layout issue or maybe overdraw issue, and what tools can you use there? And afterwards we will see how can you check that what happens on your users' devices. And I'd like to start with this number, 86%. What do you think it's about? Okay, bad question, I mean, you don't know. And that's okay. And that actually is a pretty bad number. It shows that 86% of users remove slow apps right after the first install. I mean, they just tried it, understood that, oh, I don't like it, removed. And because of this, if your app behaves not so good, probably you're in troubles. And your retention is much lower than it could be. And what is the speed of UI overall? People see different things. First of all, they want to see some feedback. And starting from Android 5, we are pretty good at it. User press something, we see ripple effect. Okay, that's nice. Then, after user press something, they want to get some feedback. For example, that something happens, actual action. And in case if everything takes several seconds, probably you won't be very good too. But all of this happens in the same time when something tries to be shown on your screen. And depending on the amount of frames that you will have, there will be different feelings of the users, how smooth the app works overall. And that's frames per second. And we will discuss this thing in particular today. So, FPS. If your app will work on 10 FPS, probably you will see it without any tools at all. If it will work on 24 FPS, it becomes a little bit harder to understand, because starting from 24 FPS, probably you know we perceive this as a motion, so probably you will not see these chunky frames directly. However, it's well known that we should strive to 60 FPS. Why 60? Because there were several researchers that shown that starting from 24 FPS and up till 60 FPS, people still see some difference. It's slightly difference, however, maybe even unconscious one, but it exists. And after 60 FPS, everything looks pretty much the same for people. So you probably shouldn't put too much effort to make it work better. And in addition, our apps, and our phones anyway, have only about 60 Hz usually of their display, and that means that you will not be able to go over 60 FPS anyway. So another question, what's 0 FPS? And it can look like, oh, that's awful. But that's actually not true. Because Android is a pretty smart system. If nothing changes on your screen, it will not be updated. So 0 FPS happens a lot, and it's okay. And the next number is 16 milliseconds. Please raise your hand if you know what's it about. 16 milliseconds. Okay, about 10-15% probably. Okay. And actually that's pretty simple. We have a second, and we want to show you or to user 60 FPS. So it means that we have about 16 milliseconds to be able to calculate and show a new frame. And what happens each 16 milliseconds? Each 16 milliseconds we'll have an event called vsync. It's a system-wide event, and when we get it, we understand that, oh, we need to show a new frame. And on some other ancient maybe platforms, it could be a case that while the display already tries to render one screen, there is another one ready, and finally you will get half of it, half of that. And that's impossible on Android because we use a technology called double buffering. So we have two buffers, and one buffer is on screen, another one is being built, and until it will be built finally, they will not be changed. So we are safe. So again, what happens on this vsync? A special Android class called choreographer starts to process user input, starts to create some animations if they exist, create views, and finally render them on the screen. And previously, if something changed, this had to be done again and again in CPU, and it's pretty complicated. So there are special things called display list. That's viewing cache, actually, rendering cache. And for each view, you will have one display list, and if something changes, this display list will be just changed instead of being recalculated from the scratch. So it doesn't contain any logic, and you can make some operations directly on this list, for example, alpha changes or some translation, and so on. And another good thing that you can move it into another thread, and starting from Android Lollipop, we have a render thread that produces these animations. So display list look like this, and going back to our 16 milliseconds threshold. Again, we have to build a frame, and we draw. We build a frame, we draw. We build a frame, and we are not able to build it in 16 milliseconds. What happens? Yep, drops frame. Probably all of you, at least who does the Android development, seen this in lockup that, oh, 100 frames were dropped, we're in trouble. And what are the reasons for this? Usually, first of all, it may be some working UI thread. For example, input-output, you are working with the database. Previously, it might be some network, but now we will crash, and yeah, it's not the case actually. And there might be some expensive operations. For example, you're working with maps, and you are trying to find some calculations, some road directly in your main thread. That's a bad idea. And another category is layout problems. Maybe you have too deep view hierarchy, or just lots of views, some overdraw between them, or problems with transparency. And these things we'll discuss today. Okay, and first of all, we will start with layouts. And here are the tools that we will use. That's profile GPU rendering, hierarchy viewer, and so on. Again, please raise your hands if you have worked with all of them. 1, 2, 3, 4, 5, 6, 7. Okay, not so bad. About maybe 10-15%. Okay, I hope you still will find something interesting here. And again, I will be glad to discuss these tools after the talk, if you want. So first of all, we want to understand if we have a problem at all. Because if we don't have a problem, why have to spend some time to solve it? And to be able to do this, we can use a tool called CPU rendering profile, GPU rendering profile. You can turn it on in developer options, and you will have some bars and lines on your screen. So the horizontal green bar shows you 16 millisecond threshold. If all of your frames are rendered faster than 16 milliseconds, all of your frames will be shown on these graphs, and it is good. And if you are going above the 16 milliseconds thresholds, probably you should pay attention on it. And what information will be on this graph? First of all, it's waiting on for the main thread. The dark green will show you some troubles. For example, if you are doing some maybe I/O or something like this in your main thread. Then you'll see measure layout, animation, input handling. It will be in brighter green, and then you can understand if you have some troubles with your UI, with your layouts. And finally, you will see some things for display lists, GPUs, or bitmaps, and all of these can give you some initial idea where should you go further. And after you have already started this thing, you open your app and you see, again, some graphs. For example, here we see that there is a lot of orange color and there is a dark green. So dark green, as I said, is waiting for the main thread, and the problem was that we have been logging something into a file system. And orange, we will discuss soon. And the interesting thing that you can use this tool even for the other apps to be able to understand how your competitors work, for example. Here we see WhatsApp, Telegram, and even SMS app on my Pixel. And you see there are a lot of different bars that go above the 16 milliseconds. And the question is why? Because like nothing happens, and especially on the last screen, that's pretty simple, but still we have this problem. I have 3 stickers, just for fun from our company. So for answers, you will get some of these. And the first question is, again, what unites all of these screens? Why do you think there might be this orange wall? What is the problem? List? Okay, good guess, but it's not the actual answer. Another ones?
Text.
Text? You mean which text?
There's a lot of text.
A lot of text, okay. No, not true. I mean, yes, text, by the way, it's pretty extensive because you should calculate its size depending on different display metrics and so on. But it's not the case in our case, here. And actually, you can look in the latest one, and it doesn't have a lot of text.
View hierarchy?
View hierarchy. I mean, yeah, overall that's a problem in the view hierarchy, but okay, last widget that is here and that wasn't named. That's not list, that's not text view, and fragment. Okay, so the answer is edit text. All of them have edit text. Because that's a text input, yeah, maybe it's not so visible in the first one, but I mean, that's messaging app. And for some reason, on the latest Android, if your edit text just pings here and there, you will see these problems that your frame will drop. And that's like stupid. And that's just directly back in Google system, and in case, for example, you will scroll your view, everything goes back to normal. And because of this, actually, user experience will not be worse because of this, because if he does something, a user, then everything works okay. But in case if you don't not do anything, you will have frame drop. So that's just a bug. And I'll tell you later how did we find it. And an interesting thing is that in Telegram, there are several views, again, with that text, and in one of them, there is no such problem. Again, Telegram is open source, and if you are interested in understanding like why does it work good on one side and doesn't work well on the other, you're welcome. Unfortunately, I'm from startup, so I had to do some other stuff instead of looking into this issue. Okay, so now we understood if, again, we are good and we have all the frames below 16 milliseconds or not. But it's just a visual thing, and it's not so convenient to look at it each time. And then we go to a tool called gfixinfo. So you can run this command in your terminal, and you will see some numbers. Yes, you can, for example, create different graphs from it, but I think that that's not the most important thing. And the most important thing is that you can get some aggregated data. It will show you how many frames were rendered at all, how many of them were junky, and what was the percentile of the speed with which you rendered your screen. And what's the good thing of this tool is that, again, because it's a terminal tool and because all of us are programmers, we can combine and automate it with our tests. So, for example, when you run your UI automator tests or espresso tests, you just run this command afterwards, and you are able to parse the data, and you are able to get your progress or regress going from one build to another. You see how many junky frames were before and how many junky frames do we have now. And as for me, that's a very important thing. Here is an example. Yeah, and as usual, all of the slides will be available later. I have actually lots of links, and not all of them are readable, so you can get the slides and go to links later. And now we're getting closer and closer to measurements, because if you can measure it, probably you can manage it. And we go to hierarchy viewer. It looks like this, so you will see some tree. You will be able to click on any node, and you will be able to see different view properties. However, for us, it's not the most important thing. The most important thing is that when you press on profile node, you'll get some colors, colored circles. And what do they mean? Depending on the stage, you will calculate measure, layout, and draw. And you will have 3 circles, and each of them will show you how long does it take. For example, green is faster than 50%, and red was the slowest. However, you should remember that all these measurements, they are relative. And that means that, for example, you can have some view that will be red, red, red. However, it's rendered in half a millisecond, which is actually a pretty good result, especially because we know that there is a text there is an image view, so that's totally fine. However, in the other place, you can have some views that will be green, 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 and it's rendered in 20 milliseconds. And as you remember, we have 16 milliseconds overall, so we're definitely in troubles. And why have we started working with this at all? as I told you, I work in startup, and even like larger companies not always go into performance. So often you don't need to think about something until you get a problem. And our problem was, I work in an American company, so once we shipped a build, everything was as usual, so we tested, sent some messages to each other, and Madrid said like, hey man, why it's so slow? And that was a problem. So what was the problem? I opened the screen and I see that, oh, it's rendered in 40 milliseconds. 40 milliseconds, what it does mean? It means that probably on average it will be like 20-25 FPS. And probably you can find that, yeah, something went wrong. However, the most important thing was not the 40 milliseconds, but 300 views that we saw this. And I mean, there are a couple of text boxes, there are some avatars, but 300 views? How? Okay, so we went into the hierarchy viewer, opened the trees, and what did we see? We saw a couple of things that looked very similar. And when pressing on one and another, we understood that in the same time we show several chats in the moment. But I mean, for what? Because the user sees only one. Okay, so the problem becomes more visible. Sliding here and there, we got to 500 views and quite a lot of milliseconds to build a frame. And afterwards, it's pretty easy to find the issue. So after fix, it took only 6 milliseconds to draw. And the problem was that we've recently moved to a framework called Conductor. Have you heard about it? Okay, some of you heard. So Conductor is a framework that you can use instead of fragments to be able to create some screens based on views instead of basing them, for example, on fragments or activities and so on. So it encapsulates logic, and Conductor claims at least that they have a little bit easier lifecycle compared to fragments. Okay, so our newcomer used the push controller method that works like a fragment transaction add. And the thing is that, could we find this issue otherwise? Yes, of course we could. But the problem is that we already have a code review, so this issue slipped through code review, and when you have a lot of code base, it's not so often easy to understand what happened wrong and at what moment. And here we just open the tool, and here is the result, and here is the fix. So at least sometimes hierarchy viewer can help you a lot and can help you fast. Another issue is redundant containers. That's clearly visible in hierarchy viewer. If you have some line of containers, one child, one parent, probably at least one of them is redundant. And actually there is even a lint check inside Android Studio that shows you redundant frame layouts. So we did it, and why does it matter? Because if you have nested view hierarchies, at least some layouts, such as relative layout or constraint layout, they require several passes to be able to render and to be measured. And the problem is that as a result, you can have a lot of different calls for the same methods again and again, like for nothing. Of course, now it's better because we have constraint layout. We are trying not to make this deep hierarchies. However, sometimes it happens. And we remove this container. And actually, we haven't seen much of performance boost. And actually, even all the numbers were more or less the same. And we'll discuss it a little bit later. But another thing that we've used and that helped us is a ViewStub. And ViewStub is a special kind of view when you tell that, oh, I want to have this layout, and when you will set visibility or inflate it, this layout will appear. But before it appears, it is not visible on the screen. So for example, here we saw that case when one view was red, so another one that's totally green is this ViewStub. And it's green because its size is 0, it has empty on draw and layout on measure, so it works like very, very fast. But you can tell that, oh, that's almost the same as making the view dynamic. But the difference is that, first of all, you will have all your layouts in one place, and not like part in XML, part in Java code, and that's, at least for me, is very inconvenient. And second, it's much easier to position this ViewStub because you will see it in preview, and especially with the nowadays constraint layout. I don't know what's about you, but I don't like to put all these constraints in code and trying to understand if it works well or not. So that's actually a pretty good thing, in my opinion. And as I told you previously, when we removed some containers, we were not sure if we have some optimization. And why? Here you see two consequent calls for this profile node, and the amount of views is the same, and the views are the same, and the build is the same, but difference is like 3 or 4 times. And why? Because when you measure something, you will always have some distribution of these measurements. There will be some average result and there will be some outliers. And here we see an outlier. And when we want to understand what is the real value, we should make the same measurement again and again for several times in order to understand what is the average one. And when we do it, it's important to test it on slower devices. Because I've already initially made up my test on MacBook Pro, and many of you, if you have worked with Android emulator before, know that, oh, Android was very slow and many people complained about it. But actually it's not the case for the latest ones on our latest machines. For example, here we see a view that is rendered in 11 milliseconds. And our primary user base is in India, and they often have lower-end devices, such as Samsung J2, for example. And a similar screen renders like 10 times slower on that phone. And that's a problem, yeah, and you should be aware of it, probably before you ship your product to final product users. So it's better to test your app on the devices that will be used by your users, and you can get it from your analytics systems such as Firebase or Yandex Analytics. By the way, have anybody heard about Yandex here? Okay, a couple of people. Okay, yeah, I'm from Russia. We have a big company, and they have quite interesting analytics. You can look at it. It's free, by the way, at Metrica. Anyway. Another thing that you should know about, you should know how to use your tools. Because, for example, here I put a system clock sleep and slide on draw. So what would you expect to see in results? 1990, so it should be about a second. Yeah, maybe a little bit more, maybe a little bit less. And again, I have a couple more stickers. Almost the same, actually. Again, who thinks that this on-draw method will be shown in hierarchy viewer as a second or like a little bit more than a second? Raise your hands. One hand. Okay. Who thinks that it will be a little bit less than a second? One, two hands. Okay, maybe someone has some other idea what will be shown here.
Like 10 milliseconds or?
Okay, you won the prize. Actually, it's even less than 10 milliseconds, less than 1 millisecond. And why? Yeah, you can choose one, maybe.
Yeah, because probably this is running on a background thread. Because the rendering thread will be sleeping, but it doesn't matter.
Yeah,
it's already done rendering.
I agree. So it doesn't matter for the hierarchy viewer what happens if your main thread is sleeping. And why does it happen? Because there is like different types of time. Wall clock time, that's the time that we are working in, that's usual for us. And actually there is a thing called thread time. Thread time calculates how many milliseconds is spent only with this thread. And when your thread is paused, it will not be counted. And as a result, for example, if you will try to, for some reason, calculate Fibonacci number in the on-draw method, yeah, you will see it in hierarchy viewer. But if your custom views, for example, go somewhere in database and wait for a result, in wait async and so on, so you will not see this in your tool, and you should be aware of it, that it will not show you all the problems that you have in your code, even if it's bad, actually. And another thing, just bonus for curious people, using hierarchy viewer, you can get a display list for any view. I don't know if you'll be able to find some like real usage of this information, however, you might find it interesting. So, conclusion. When you do measurements, it's important, especially with hierarchy viewer, to do it several times and to be able to understand what's the average value. Red is not always bad, and everything is relative. And because of this, optimizations should be based on numbers. And the most drawback of the hierarchy viewer is that metrics can be taken only in a manual way. And what does it mean? That you will not be able to automate it and to add it, for example, to UCI easily. And we could hope that, oh, it will be fixed somewhere, but unfortunately hierarchy viewer is no longer being developed. And now Android team suggests us to use layout inspector. However, it doesn't have any means to profile your layouts at all. So still hierarchy viewer is working. Hierarchy viewer can help you in some layout problems. So I think that you should know how to use it. Actually, what Google suggests to use is frame metrics API. However, you will have to add this code to your app. You will have to do it somehow manually. So it's, as for me, it's not the best replacement for hierarchy viewer. However, you can still use it if you need. And another problem that happens a lot with different things is overdraw. For example, if you turn it on again in the back panel, you will see some colors on your screen. And what do they mean? For example, here we see that background is green, and it means that it has 2x overdraw. So we have some pixel, and we put something on over this pixel 2 times, so just waste our time, basically. And actually, there is a decor view that's not counted here, so this background was repainted 4 times. And again, hierarchy can help you, because you can export your view hierarchy into PSD file. You can open this PSD file in any image editor, and you can see that, for example, on some views there is the same white background. And it might look like a stupid mistake, however, sometimes it happens, because now we often have activity. Inside activity we have fragments, inside fragment we have a custom view, and sometimes they have these overlapping backgrounds, and that's an easy way how to understand that you have this issue and how to fix it. So after we removed just a couple of backgrounds, almost everything went back to good state. However, here on top you can see that there is still one red view, and this view is avatar. And initially, this was our custom implementation. It was read in overdraw. We had 4 layers of implementation because we needed to show a letter instead of we needed to show an image and all of this stuff. And we thought that, oh, okay, let's see what are the other ways to do it. So we find some ready solution. It's a library from a company. There is a post describing this solution, and probably I will be right if I will tell you that if you have, for example, 2 libraries, and there is a post describing my library, so you probably will stick to this library with post, because, oh, guys probably don't know what do they do. And so did we. Overdraw is blue. However, Frederick took 50 milliseconds. And the post was about, oh, it's so easy to use Canvas, so let's do everything like on Canvas, and it will be fast and cool and without like overdraw and so on. But the numbers tell that we shouldn't use it. So again, it's obvious that sometimes existing solutions are better, sometimes your bicycles may be good enough, and it's very important to measure it. So what did we achieve again? We understood that overdraw is very easy to check. It's quite easy to solve, usually. However, for us, measurements told that improvement is not so big, and actually it was like nothing. And I had a talk with Roman Guy from Google, and he told that, yeah, even if the Google site, Google developer site, just still have a notion that you have to try to make your app work not more than 2.5 of this overdraw. However, now it's not so important because hardware like going higher and higher, better and better. But still, there are some cases when overdraw may matter for your app. So if you've tried other things and they haven't helped, you can try this. But probably you shouldn't spend a lot of time on it. And well, when we talked about how can we calculate these numbers, another thing is CPU profiler. And previously there were different tools, different systrace, that was a standalone app, and there was a trace view inside Android Studio. But now all of this you can find in Android Studio. So you can make either method tracing, either system tracing. Again, there are several other presentations about how to use them, because there are like a lot of different things about it. But I would like to show you at least one example. So, and this example is about nested scroll. It happened about 2 years ago, and probably you often see apps like this. So we have some recycler view, and you can scroll it. I mean, nothing interesting. And at that moment, what can happen? That you have, oh, very important message that should be shown like always, and it should be on top of everything that's licensed in your recycler view. And you think that, okay, I don't want to mess with all this get view by type and so on, so I'll just put a nested scroll view, I will get layout, linear layouter, and everything will be fine. And it really will be fine until you have, I don't know, like 5, maybe 10 views inside of this hierarchy. But as well, when you start to put something more there, you'll have the same problem. And here is, again, if you by some accident run into this case and you saw that, oh, our FPS is low, here is how can you find it. First of all, you could open CPU profiler, and then you will see different bars again. And the width of each bar shows you how much time did you spend to process this method and its children. And for example, here we see some big blob of data. So we're going there, and we see that choreographer to frame took about 2.5 seconds. So that's pretty much. And okay, we're going down, and what do we see? That there are methods called measure child, and for some reason there are like tens and tens of them. And we have only like a couple messages, and all of you know that recycler viewer was created to be able to recycle these views, so we definitely shouldn't have so many calls there. And if you see something like this, then it's probably easier to understand that something went wrong. And actually you can find in Android documentations for scroll view such thing that you should never use a scroll view inside the list view. And actually it's the same that you should never use a nested scroll view with a recycler view. And there are some other things that you shouldn't do, and often you can find it using some kind of CPU profiling. And for example, here the issue is that when you use recycler view inside the nested scroll view, it thinks that, oh, okay, I have as much space as I want, and because of this, it just tries to create and bind all the views at one time. And like when you switch to the screen, you will definitely have a big frame drop. And again, there are still hundreds of questions about this recycler view and nested scroll view issues. So it's still actual problem, because always we have some newcomers to Android, and they tend to get into the same errors until they will not be explained. And another thing that appeared from Android 9 or Android Pie, now you can get systrace directly from your phone. What does it mean? That you can add custom traces to your app. For example, that, oh, I know that here something went wrong, so I add some custom traces. Again, you can find it in docs. And then we ship this app to our testers. Testers just press a special button in the notification panel, and then they can send you a syslog, and you'll be able to understand how much does that or another part of your code run. And when you work with CPU profiler, again, there are two main categories that you can use, as I said. That's method tracing and system tracing. Method tracing instruments your app, so you will see initially more data in it, just by like automatically. But the drawback is, because it instruments your app, it will influence your speed. And for example, here we see that one of the screens took, one of the frames took 150 milliseconds. And if we use system tracing to calculate the same thing, it will be a little bit less. And again, depending on the screen, the difference might be bigger. So again, Android says that for method tracing, you should use it just to be able to compare like what was there, what was here, but you shouldn't make some results, something like, oh, the screen takes 20 milliseconds, because it might take even like 16 or less, and that's not a concrete number. And system tracing is based on Android, and it's in Android Core, so it will give you more precise values if you need them. And after we've created everything and we understood how bad and how good does it work, we want to understand how does it work on your user devices. And what can we do? We have a tool called Android Vitals that's already working for you, even if you don't know it, if you use Google Play services, and you can find all the data already in your dashboard. So if you haven't used it, yeah, by the way, please raise your hand if you used Android Vitals, or if you use it. Like 30 or 40%. So yeah, if you haven't do this, I suggest you to go to Google Play Console. There will be a section, performance or something like this, and there will be Android Vitals. So yeah, and just opening this screen, you will get already a lot of different data, a lot of different graphs that will show you how good or how bad your app works. For example, you will see how many frozen frames you have. And frozen frame is a frame that was not rendered in 700 milliseconds. You will see what is the average render time for different percentiles and so on. And sometimes you will even see some anomalies. For example, the anomaly with that input in edit text we found using this data. So initially the question was, oh, why do we have like two normal distributions here? Because it's strange. And then we started to go deeper into our profiling and understood that, oh yeah, on like our main screen, we have less frame rate just because of this cursor. And what does it mean? It means that actually our users did not feel bad because of this, because again, this problem happens only when you do nothing, and probably you will not notice that your cursor going like back and forth with 30 frames instead of 60 frames. However, it spoils your data, and it will be harder for you to understand if you have like real problems. That's sad, but you should just count for it. And additional thing that you can use to better profile and to better understand what happens on your phone's users, called Firebase Performance Monitor. So again, you can add this library. It's actually from Firebase, and you can tell that, oh, start trace, stop trace. And as a result, you will see in the network panel, I mean web panel, how much did this trace took on average. And as a result, you can understand, for example, how long was on-create of some activity happening, or how long was happening some particular method, and so on. And that will be data from your devices. By the way, one more comment about Android Vitals. Android Vitals starts collecting data only from Android 7 and higher. So if your primary users are like have Android 5 or 6, you'll not get that data, unfortunately. But let's see how soon we have Android 7 and higher, like on all of the devices. And to conclude, I would like to give you next reference. Instagram, in their post, told that they spent about a year just reimagining and redesigning how their Android app works. And of course, not all of us have this possibility to spend a lot of time of several Android engineers or like software engineers to be able to make it better. However, in my opinion, you should always understand at least where you are at now. I mean, again, if you should bother with this profiling or you shouldn't. And if after this presentation you can't use Android Vitals or you can't use GPU profiling and you will go to your work and open it and see that, oh, I need improvement, or oh, I did a great job, so that's great. And I suggest you to do this. So that's it. Thank you that you come here, and I am open to questions.